welcome to the first podcast episode of Radiology AI. My name is Dania Daye, and I'm the Associate Editor for Social Media for Radiology AI. Today, we're very excited to launch our podcast series for the journal. The purpose of our series is to discuss the science and emerging applications of AI in radiology. We will achieve this goal by highlighting the articles published in the journal through interviewing many of our authors and a number of leaders in the field of artificial intelligence. The podcast will be taking place every other month in its first period. Please rate, review, and subscribe to our new podcast series on any of iTunes, Google Podcasts, and Spotify. It is my pleasure today to introduce my co-host for the podcast, Dr. Paul Yee. Paul is a fourth-year radiology resident at Johns Hopkins University and a member of the Radiology AI Trainee Editorial Board. Today, we launched the podcast series, and Paul will be interviewing Dr. Chuck Kahn, who is the editor for Radiology AI and professor of radiology at the University of Pennsylvania. Paul, I will turn it over to you now.
Thanks for the introduction, Dania, and a special thank you to Dr. Kahn for joining us here on the podcast today. So Dr. Kahn, you have been involved with informatics and radiology for quite a while now. You're the vice chairman of radiology at Penn. You're a fellow of SIM, and now you're the editor for Radiology AI. Can you tell us a little bit about your background and how you got interested and involved with AI in radiology?
Sure. Well, first, I just want to say thank you to you, Paul, and to Dania for starting these podcasts. I think this is going to be a wonderful addition to the resources that the journal is providing. So before I went into medicine, I was a math major and had always been interested in applications of mathematics and computer science in medicine. And when I found myself in radiology, I became really interested in ways that one could apply various approaches to improve decision-making. And in fact, the very first project that I did in a research project in radiology was a tool to help guide referring providers to the most appropriate imaging procedure, and use that as a way to take knowledge that was in a variety of reference sources and turn it into something that people could act on. The idea being that you really need to bring knowledge to the source of decision-making, making it something that people can use as part of their day-to-day clinical practice. And I guess that's kind of what got me started down the road of working in AI.
Yeah, that's really interesting. I saw that you had actually gotten a master's in computer science in about 2003. Was that informed by your prior experiences and your interests in applying math and some of these theologies?
After being in practice for about 20 years, I guess, I ended up taking a sabbatical year, during which I went and pursued a master's in computer science. And although I had done a lot of programming work, in fact, I worked my way through college and through at least half of medical school up until hitting third year clerkships and not having much time left over. But I doing computer programming, but I had never actually taken a computer science course. So it was really kind of a thrill to step out of the clinical world of radiology for a little bit and to get some training in the foundations of computer science. So actually kind of had three areas of concentration in that. One was bioinformatics. One was theoretical computer science, and the third was artificial intelligence, machine learning. And I thought all three of them actually were helpful to me in formulating some of the ideas and helping to bring approaches to bear on some of the things that I had been working on.
Yeah, no, thank you for sharing all that. I think that's a really unique background. And I think it's really rare to have a radiologist who has formal background in computer science and has had the experience early on with informatics and machine learning more specifically. So in light of that, when you look ahead at the next 5 to 10 years, what do you see as the most likely ways that AI might shape radiology, specifically, and maybe medicine as a whole?
Well, I truly believe that the best way to predict the future is to build it yourself. It's we really don't know where things are. I think, well, I will tell you that artificial intelligence is right now, everyone thinks of deep learning, which is a particular technique for machine learning, which has gotten a lot of attention. This is the approach that allows us to recognize that a picture is a cat rather than a dog by training it with sets of images. But in fact, AI is so much broader than machine learning. There's all these other aspects to it. And in fact, some of the technologies that we take for granted in much of what we do are actually things that have arisen out of the world of AI. The user interface that most of us deal with on our computers is a product of AI. Speech recognition, which is there in Siri and Alexa and all these other technologies, that's work that has grown out of the world of AI. So I think there's a huge opportunity, but in the very early days of it, such as where we are right now, I think that people have looked at AI and said, oh, this is going to push radiologists out of a job. There'll be no room anymore for physicians to be working in this area. And I don't believe that. I think, in fact, AI is going to open up huge new opportunities for us. It's going to make it an exciting time for us to do these things. And I think it's going to really create new vistas. And in some ways, I guess I look at it kind of the same as when MRI was first introduced. And everyone said, well, we won't need pathologists anymore because we'll be able to diagnose tissue type right from the MRI. There won't be a need for diagnosis because we'll know everything from the imaging. And it's funny now to look at it some decades later and kind of realize how laughable some of those statements were. But that was the feeling at the time. And in fact, we know now the limitations that MRI has, and it's a tremendously powerful tool, but it doesn't do everything. And there's still a role for us to help decide how best to apply it. And I guess I look at that in part as where some of the techniques with machine learning will be, that will be able to drive forward and advance our abilities and improve diagnosis. But I think people have yet to realize that all of these techniques have limitations to them, and we have to be mindful of them. And in fact, it's going to be the radiologists who are going to be best positioned to help understand those limitations and help to protect our patients in a way by recognizing those limits and assuring that the systems are used appropriately.
Yeah, I think that's a really interesting thing to point out, that, although we think a lot about deep learning, as you mentioned, that AI really has been here for a while. And, it sounds like it really is incumbent on radiologists to take the lead and sort of write our future, as you mentioned. So in light of that, I want to talk about the Radiology AI journal. I think this is one case where we're seeing radiology and the RSNA specifically trying to be at the forefront of this. Can you tell us about the origins of the Radiology Artificial Intelligence Journal?
Sure.
And maybe how it came about?
Well, so as you probably know, we have RSNA has published two really extraordinary journals, one being the Gray Journal, Radiology, which focuses primarily on science, and then Radiographics, which provides educational content. And increasingly, we've been seeing really a lot of very good content coming into radiology, but they have just had a limited page budget that they were able to include along with the journal. And so the RSNA board decided to craft 3 new journals, one of which is Radiology Artificial Intelligence, the other 2 being Radiology Cardiothoracic Imaging and Radiology Imaging Cancer. And all 3 of the journals launched in 2019. Radiology AI was the first one out of the gate. And the mission that's been given to us is to publish the same high quality of science, original research that is published in radiology, with a focus for us on applications of artificial intelligence. And so that's the mission that we've taken on. And so we're interested in publishing high quality work that describes applications of AI in radiology, and in particular showing the clinical benefit. There are, I will say, a lot of publications of various algorithms and mathematical techniques and various approaches that are out in the technical literature. But as physicians, it's really important to us that we bring those techniques home and show how they impact the care of our patients. And that's what we seek to do in the journal.
Yeah, I totally agree. It's really important that amidst all of the technological innovations and excitement, that it's really about how does this play out clinically. And so in that regard, do you think that research in AI differs from traditional radiology research? And if so, how? And on the converse, are there similarities that maybe some of us might take for granted or not necessarily assume with traditional radiology research?
That's a great question, Paul. In fact, much of the research that's been done in AI, in machine learning, in radiology, really has focused on classification. It's right. Being able to take a radiograph and to arrive at a diagnosis and to say, does this patient have a pneumothorax? Do they have a pneumonia? Is there cardiomegaly on a chest radiograph? And in that way, the criteria that one applies to that work in terms of being able to judge the quality of the science really is very similar to that of any other technique. If I said to you, is CT better than ultrasound for diagnosing appendicitis, you'd say, well, I need a suitably powered clinical trial. I need the right number of patients. I need to know that these things were read by people who knew what they were looking at, and all of the things that go into that type of analysis really have to go into AI, because the question is, can we pit the computer against, in many cases, a human observer? There are some differences in that there are some aspects of AI, and particularly because of the work that's done in deep learning. Deep learning involves hundreds of layers in these neural networks. I think all of us have, from medical school, in our minds the picture of the visual cortex, and we can kind of get the idea that one can have connected layers of neurons, and that's in many ways what artificial neural networks seek to emulate. And in the early days, because of the limitations of computer capability, hardware predominantly, you could have 3 or 4 layers of these neurons. Now we typically put together hundreds of layers of these things. And because of that, there are effectively millions of parameters that these models are learning. And this is one of the challenges for us. So when people build a model and then proclaim that it functions well, we really need to have a mechanism to understand exactly how they built that model so that we can assure that it has been evaluated appropriately. And if I may, I will only mention as cautionary tale, I think
Sure.
many, some of our listeners may be familiar with stories about the system that people developed to diagnose TB on chest radiographs, and they trained it with sets of a large number of chest radiographs, and the system demonstrated remarkably good performance until someone noticed that the images of patients who were positive were all coming from the TB clinic, and in fact, down at the bottom of the radiograph, stamped onto the radiograph, burned in digitally, it said TB clinic. And the computer, in its wisdom, had actually identified that and figured out that that was the feature that distinguished patients that had TB from those that did not. So all of these things, and because of the potential for systems to learn features that are unintended, we have to just guard against that, and we have to be very careful and thoughtful about how we evaluate scientific work that relates to applications of AI.
Yeah, no, thank you for a really nice broad overview of how AI kind of differs, as well as is similar to traditional radiology research. In light of these special or nuanced considerations for AI research, such as finding these potential confounding factors in images, can you comment on any standards for evaluating AI studies, both for reviewers evaluating studies for publication, as well as for readers of these articles that might be coming out?
Well, typically, there are a number of standards that people have used. One of them that's very common for studies of diagnostic accuracy that people may know of is STARD, STARD.
Right.
Other ones such as Prisma and Consort that are used for aggregations of data and various clinical trials. One that we have published is called CLAIM, Checklist for AI in Medicine, or pardon me, in Medical Imaging, Checklist for AI in Medical Imaging, CLAIM. And our goal is to articulate the particular aspects of machine learning models in particular that need to be described in order for a reviewer and for a reader to really understand the work that someone has done. And as with all areas of science, it's critically important that we make sure that work is reproducible, that when someone makes a scientific claim, that it's not something that no one else is able to do. And that reproducibility is a key aspect of science. So we really have strived in formulating this checklist to provide to get authors to provide the information that's needed to help reviewers and the journal readers to understand the work that they've done and to have confidence in it. Because truly, that's what we want to be able to do when you and I open up a journal and read an article. We really want to know with a pretty good sense of certainty that the material that's provided there is truthful and is correct and is something that you and I can base our scientific investigations on or base our clinical decisions on. So it's really critical for us as readers of journals, as contributors, and as reviewers of journals to be able to think critically about articles and to be able to have the information at our fingertips to allow us to decide what's good science and what might need a little work.
Yeah, I agree that these standards are really important for both transparency and also, like you said, upholding the quality that the RSNA journals have been known to uphold. As we come to a close, I'd like to ask you about, what are you personally most excited about for the next decade in AI and radiology or informatics or medicine in general?
Well, that's a great question. I honestly, I think we have an opportunity to use the tools of artificial intelligence to really help us improve the care of our patients. I think there is a phenomenal opportunity for us to improve diagnostic accuracy, to be able to extend the use of imaging to answer questions we couldn't answer before. Some of the work that's being done in radiomics is tremendously exciting, where we're able to look at features that are not things visible to the human eye necessarily. I mean, when we look at mammograms, for example, yes, we may look for nodules. We look to see if the margin is spiculated and if what the density of it is. But actually using the characteristics, the information from the images, we can start to look at things that go beyond what the human eye can see. And in fact, I think this technology is tremendously exciting because it allows us to do virtual biopsies of tissues that link the imaging phenotype, the patterns that we see in imaging, and to link that to actual the genetics and the gene expression profile of lesions. And for people who have cancer, for example, where they may have, let's say, a colon cancer that has metastasized to the liver, each of the metastases to the liver may be somewhat different metabolically and in terms of tissue and even within the lesion. So it allows us to really think about precision medicine. My personal thought, I'll just say real quickly, is I think 10 years from now, much of the work that we're doing in machine learning and AI, it's going to be kind of like where we are with CT and MRI. It's going to be a modality. It's going to be a tool that we recognize that's part of our armamentarium that helps us better diagnose patients and manage them and contributes information. I don't think it's going to replace us. I think it's going to change what we do, but it's going to give us new capabilities and open up some exciting vistas. And I think one of the things that we may see coming to the fore as a new aspect of artificial intelligence is in the area of robotics, actually. And I think that's where 10 years from now, some of the excitement may well be, but we shall see.
Yeah, no, thank you for that. And as a closing question, what is one piece of advice you would give to radiologists, either in practice or in training, who are interested in learning more about AI?
That's a great question. I don't think I've argued that we don't need everyone to learn Python and we don't need to turn radiologists into computer programmers. That's not going to help. We really want radiologists to be physicians and consultants. But in the same way that we are trained in medical physics and we're able to converse with our physics colleagues, we really want the radiologist of the future to have enough understanding of AI and data science to be able to converse with data scientists, because I think they're going to become important parts of our radiology departments. And AI is going to be a modality, and in the same way that we have a medical physicist who checks the CT scanner every morning and does calibration and checks dose, we're going to have data scientists who check our AI algorithms and make sure that they're functioning properly. And we, as the physicians responsible for the operations in our departments, need to be skilled and have enough understanding of the language of AI to be able to converse intelligently with them and assure that these things are working well for our patients.
All right. Well, thank you so much, Dr. Kahn. Just want to thank you for your time, for sharing your wisdom and experiences over course of informatics, AI, about the journal, and the future.
Well, it's a pleasure. Thank you.
Yeah, thank you. And big thank you to the RSNA for starting the journal, for sponsoring this podcast, and to my co-host, Dania Daye.
And thank you, Paul and Chuck, for a great discussion. To our listeners, thank you for tuning in for our first episode for the podcast series. Don't forget to rate, review, and subscribe to our new Radiology AI podcasts on any of iTunes, Google, or Spotify. And please stay tuned for our next episode.